Hello and welcome to Physics Platter. Today in Physics Platter we will be deriving the displacement of a body in nth second. If a body is moving with some velocity or acceleration at nth seconds or in nth second, how much displacement will the body will have, right? So what will we do is we will prove the final equation for the displacement of the body in nth second, both numerically and graphically here. Alright, okay. So before that we must understand what is the meaning of nth second. Nth second. For the immediate example, we can give an example of, let's say, in this pandemic situation, we can say that in 5 days, let's say somewhere in 5 days, the total infected people are, let's say, 5,000. Okay, total infected people in 5 days are 5,000, let's say. Okay, and then let's say on 6 days, total infected people becomes 6,000, or let's say 7,000. Okay, if we have to find what is the total number of infected people on 6th day, what will we do? Of course, we will say that on 6 days there are 7,000 people infected, whereas on 5 days there are 5,000 people infected. So 6th day means that on that particular single day, how many people got infected? Of course, the number of people infected on 6 days minus number of people infected in 5 days, right? That means we can also say number of people infected in 6 days minus number of people infected on 6 minus 5 days. Alright, so 7,000 minus 5,000 equals to 2,000 people. That's the number of people infected on 6th day, that particular day. Alright, similarly, if we talk about 6th second, let's say a particle is moving with some velocity. Let's say let's first consider the particle is moving with constant velocity. Okay, if the particle is moving with constant velocity, means what? In every second the particle is moving v meter. What is the definition of velocity? Velocity means if velocity is 5 meter per second, that means the body is moving 5 meter in every second. Let it be 5th second or 6th second or 100th second or nth second. Any second, the body is moving 5 v meter. Alright, so here in nth second also simply we can say the displacement of the body Sn, S equals to v meter for constant velocity. Okay, now what if the particle is moving with a constant acceleration? Now the body is moving with constant acceleration means what? The velocity is changing. Velocity is not constant, but it is increasing constantly, where a equals to constant. And we have to find how much is the displacement of the body for nth second. For that, what will we do? We will simply find the displacement of the body in n seconds. Okay, if the displacement of the body is n second is given as Sn, so displacement of the body in n seconds, let's say, and Sn minus 1 is the displacement of the body in n minus 1 second, let's say. Then nth second, on that particular nth second, what will be the displacement? S will be simply Sn minus 1. So displacement of the body in n second minus the displacement of the body in n minus 1 seconds. Alright, now we will apply the formula equation of motion here. S equals to ut plus half a t square, where u is the initial velocity, t is time. A is acceleration. Okay, so here u is same for both the times n or n minus 1, because u is the displacement velocity of the body when t equals to 0. Alright, so here Sn means n equals to t, that means s equals to, here Sn equals to what, un plus half a n square, because t equals to n here. Alright, Sn minus 1 equals to how much, un minus 1, because t equals to n minus 1 here, plus half a into n minus 1 whole square, t equals to n minus 1 here. Alright, therefore we can say that in exactly n second, the displacement of the body equals to Sn minus 1 equals to un plus half a n square minus un minus 1 minus, because of the minus sign here, half a n minus 1 whole square equals to, we will simply break the brackets here. So un plus half a n square minus un plus u minus half a into n minus 1 whole square is what, n square minus 2n plus 1. Alright, equals to un cancel, so half here becomes u plus half a n square, we will break the bracket here also, so half a n square plus half into a into 2n minus half into a equals to u plus half a n square again cancels each other. Therefore, if we take half a common here, then it becomes 2n minus 1. So that's the formula for the displacement of a body moving with constant acceleration in nth second. Alright, s equals to u plus half a into 2n minus 1. Here if we consider the velocity of the body is constant, that means the body is moving with uniform velocity, let's say, then also then means what, a equals to 0, constant velocity means a equals to 0, therefore this one becomes 0. So in nth second the displacement of the body will be u, which we have already discussed before, right. So this one proves our previous logic for body moving with constant velocity also. Alright, so that's how you prove the displacement of a body, equation for the displacement of a body in nth second numerically. Now let's prove the same equation graphically. Okay, graphically, of course, we will take velocity time graph. In velocity time graph, what do you know? The area under the VT graph is the displacement of the body. Alright, so let's draw a VT graph. For a body which had an initial velocity u, this is u, let's say the body starts from A. If the body is moving with constant acceleration, after time t, the graph would look like this, right. So let's say this is my n second. So at n second the velocity of the body is, let's say this is B point, this is C, let's say this is D. So BD is the final velocity here. BD of course is the final velocity at the end of n seconds, which is equals to V equals to U plus AT. As we know the equation of motion, first equation of motion, right. If the body was moving with constant velocity, it would go like this. If we remember the proof, we have done it like that, proof for the equation for the displacement of the body, right. So if this is C, okay. Now in n minus 1 second, let's say this is, so what is the displacement in n second here? The displacement in n second equals to the area under O A B D, area of the trapezium O A B D, right. area under OABD would be the displacement of the body in n seconds. Alright, let's say n minus 1 is somewhere here, n minus 1 second. So at the end of the n minus 1 seconds, let's say this is E, let's say this is E, this is G, let's say, and this is n minus 1 seconds. So at the end of the n minus 1 second, what is the velocity? Velocity is E G, which is equals to V n minus 1 second, which is also equals to U plus T is, sorry, here T is of course U plus A n, right, and here T is n minus 1, therefore U equals to V n minus 1 equals to U plus n minus 1 A into n minus 1, because here T equals to n minus 1. Okay, so that's the velocity. Okay, therefore my S n minus 1, so n minus, in the displacement of the body in n minus 1 second would be the area of the trapezium, O A E G, this area, this trapezium, right. Therefore if we want to calculate the displacement of the body in nth second, that would be S n second, displacement of the body in n second minus the displacement of the body in n minus 1 seconds. That means that would be the area of the trapezium, O A B D minus area of the trapezium O A E G. Okay, so this area minus this area, which means, which is equals to this shaded area, which is equals to area of B D G E, area of the trapezium B D G E. Okay, now we know the formula for area of a trapezium is half into the sum of the parallel sides. Here the sum of the parallel sides are what? EG and BD. So BD plus EG, let me write the formula first here, equals to half into area sum of parallel sides into distance between them. So parallel sides are BD plus EG, into distance between them is what? GD. Alright, GD equals to half into BD is what? Here I can write GD, let me write it here, GD equals to 1 second, of course, A equals to constant. Okay, GD is 1 second. Why? Because D is n second, G is n minus 1 second. So if you subtract them, there is only 1 second, that's the nth second. Alright, equals to half into BD. BD is what? U plus AN, U plus AN plus EG is a velocity in n minus 1 second, which is U plus A n minus 1. So U plus A into n minus 1 into GD is simply 1 equals to half into U plus U, 2U plus AN plus, if I break the bracket here, it becomes AN minus A. Okay, equals to, if I break the bracket here again, it becomes U plus AN plus AN 2N. So half into 2AN minus half a, okay, equals to u plus, if I take half a common from both the sides, both the terms, then it becomes half a into 2n minus 1 is equals to this, which is the displacement of the body in nth second, alright, which is the same as we have found in numerical proof, alright. So, this is how you prove the displacement of a body which is moving with a constant acceleration in nth second, nth particular nth second, alright. Okay, I hope you have learnt the proof here. If you have any question, queries or suggestions, please write me in the comment section. I will try to answer you in my next video. Okay, and also subscribe to my channel, and then keep the bell icon selected so that you don't miss any of the videos, because the videos will be coming very regularly this time from the next week, so don't miss any of them. Alright, so that's all from today's video. See you in the next video. Till then, take care.